Howdy folks, it's Mr. Ryan again, and in this video I'm going to show you how to solve an algebraic inequality that I call a between inequality. Let me show you what I mean. Let's say that I have an algebraic inequality that looks like this. Let's say that I have, let's say 4 is less than or equal to 2x minus 6 is less than or equal to 10. Okay? And what I want to show you here is we now have two inequality symbols. And we have the variable in the middle, and the easiest ones typically have the variable, the x or whatever, in the middle, and it probably should be in the middle. And then you'll have a value over here and another value over here. There can be a little more to it than that, but if you follow the correct rules of algebra, then you should have no problem solving this. Now, the one big difference in solving a between inequality is this. See, in algebraic equations, and in the previous inequalities that we discussed, what we said was that the rule of algebra is whatever you do to one side, you have to do to the other side. But now there's not only two sides. There's a left side, there's a right side, and there's a middle side. There's three parts to this inequality. Now, because of that, what we're now going to say is the golden rule of algebra is whatever you do to one of the three parts, you have to do it to all three of the parts. Okay, so algebraically, what would you want to do to this expression to make it simpler? See this minus 6, wouldn't you want to add 6? That's an additive inverse. So let's add 6 here. If we add 6 to the middle, we also have to add 6 to the left, and we also have to add 6 to the right. Now, that's going to cancel the minus 6 in the middle. 4 plus 6, that's 10. Carry down the inequality symbol. Carry down the 2x. Carry down the inequality symbol. And then 10 plus 6, that's 16. Okay? Now, if we look at the x, we can see that it's being multiplied by 2. So the next thing we'd want to do here is divide by 2. Well, if I divide by 2 in the middle, I need to divide by 2 on the left, and I need to divide by 2 on the right. That'll cancel the 2. And now on the left, 10 divided by 2 is 5, so we'll bring down a 5, bring down the inequality symbol. Here, the x is all that's left over. Carry down the inequality symbol, and then 16 divided by 2 is 8, and we have a solution. The solution is that in order for this between inequality to be true, then x would have to take on some value between 5 and 8, inclusive, meaning it has the or equal to, so we can include 5 and 8. How would we graph this? Well, I've already shown you how to do this in a previous video, but let's review. If I take my arbitrary number line here, I suppose I can put in, I'll start at 4. I'll go 4, 5, 6, 7, 8, 9, 10. At my 5, I have an or equal to, so at my 5, I'll put in a closed circle. At my 8, I also have an or equal to, so I'll put in a closed circle. And then x, all my values of x should be between 5 and 8, and therefore I will shade in the region between. And now this is limited. It starts at 5 and ends at 8, and all the numbers between are a part of the solution. Okay, that is a between inequality. Let's try one more example. See if I can find one over here. Yeah, that'll work. Let's see here. Let's try one like this. Let's say that we have a 3 over here, and let's say that 3 is less than, let's say we have negative 2x minus 5 over 4, and we'll say that that's less than 7. There we go, less than 7. So we've got this between inequality. And so the first thing I want to do is I don't like this denominator of 4. I want to get rid of the fraction. So if I multiply by 4, I can cancel the 4 as the denominator and I won't have a fraction anymore. But if I multiply this by 4, I have to multiply this by 4 and this by 4. All parts we have to do the exact same thing to all the parts. So if I multiply this times 4 and this times 4, I can multiply this whole thing also by 4. 4 times 3, that's 12. Bring down the inequality symbol. 4 times this fraction, all that's going to do is cancel the denominator. So I'm going to carry down the negative 2x minus 5. Bring down the inequality symbol. 4 times 7, that's 28. The next thing that I want to do is I want to get rid of this minus 5 right here. So to get rid of the minus 5, I'm going to do the additive inverse, which is positive 5 or plus 5. So I'll add 5 here. If I add 5 here, I have to add 5 over on the left, and I have to add 5 over on the right. In the middle, that's going to cancel the minus 5. 12 plus 5 is 17. Carry down the inequality symbol. Carry down the negative 2x. Carry down the inequality symbol. And 28 plus 5, that's 33. We're working our way towards a solution. Now in the middle, you can see that we're about to divide by negative 2. Okay? So I'm going to divide by negative 2. And if I divide this by negative 2, I have to divide this by negative 2. And I also have to divide this 33 by negative 2. But stop for a second. I hope there's something ringing in your head. Hang on a second, Mr. Ryan. Don't forget our rule here. If you multiply or divide by a negative number, then you have to switch or reverse the inequality sign. I'm going to change this. You have to switch or reverse the inequality signs. We got to switch both of them. So now, when we bring this down, it's going to be negative 17 over 2, but this less than symbol has to become a greater than symbol. We're going to cancel the negative 2 and carry down the x. Over here, this less than symbol has to become a greater than symbol. And then we'll carry down this negative 33 over 2. Now this is a little weird here because normally we don't say that x, we usually put our smaller number on the left and our larger number over on the right. Okay? So what we're going to do is we're going to flip this around. We're going to put negative, oops, that's kind of ugly. We're going to put negative 33 over 2 is less than, x is less than negative 17 over 2. And if you're not sure, let me show you. On a decimal, 33 over 2 is the same thing as negative 16.5. Negative 17 over 2, that's about the same thing as negative 8.5. And this number, negative 8.5, it is larger than negative 16.5. This is more negative, so this is smaller than this number. That's why x can be larger than this number, but smaller than this number. Okay? So, we want to draw our graph now. And what I'm going to do is, I'm going to make that my negative 33 over 2. And then I'm going to do, watch what I'm going to do here. Well, let's see. I'm going to put a bunch of these. It's kind of weird what I'm going to do here, but I'm going to skip some. I'm going to go negative 33 over 2. Then I'm going to skip, I think, 4. Yeah, I'm going to skip 4, and I'm going to put negative 29 over 2, then negative 25 over 2, then negative 21 over 2, then negative 17 over 2, then negative 13 over 2, and negative 9 over 2, and then negative 5 over 2. And as long as all of my numbers are evenly spaced, that's why I can put any numbers I want on this arbitrary number line, as long as they're evenly spaced. And I know that where my negative 33 over 2 is, I'm going to put an open circle. And where my negative 17 over 2 is, I'm going to put an open circle because I do not have or equal to, and my x is between them. And so I'll do this, okay? And this is my solution. You might say, Mr. Ryan, I don't like those fractions. Okay, well then you could simply start at negative 16, or maybe negative 17, negative 16, negative 15, negative 14, negative 13, negative 12, negative 11, negative 10, negative 9, negative 8, and then you could put your negative 17 over 2 right here, and you can put your negative 33 over 2 right here and draw your graph. Okay? Just do it whichever way is correct and consistent with something that you're comfortable with. Okay? But this is another between inequality, And in this one, we had to cancel a denominator, and we also had to divide by a negative, so we had to reverse the signs. I just wanted to give you some variety and show you some of the things that you may have to do in some of these solutions, okay? Well, that's all I have for you for solving between inequalities, and I'll see you in the next video where I show you how to solve absolute value inequalities.